Okay, so in this video we're going to talk about expanding the square of binomials. So I'm just going to go over the rules for the square of binomials. And for the first one, if we have a binomial where we have an addition, then the rule says that this will be a squared plus 2ab and then plus b squared. And then if you have a difference, right, a subtraction in a binomial, then this will be a squared minus 2ab plus b squared. Now I want to clarify that for a, right, we're always using the same a value that we have on the binomial. And then b is the second term. So if you are able to identify your a and b, then you can go ahead and plug everything in the formula and just do the expansion from there. Now this is a rule that was created because they noticed that every time you will do the FOIL method or the, just a distributive property into a binomial that was multiplied by itself because it's square, they were always getting a solution that had a squared plus 2 times the multiplication of ab and then plus b squared, or a squared minus 2 times the multiplication of ab and then plus the b squared, right? So this is just a quicker way of solving this type of problems when you have a binomial and it's squared. So let's say we have r plus 10 square. Okay, now just to let you know, this is actually r plus 10 times r plus 10. I do not want to see that you write this as r squared plus 10 squared because that is not the answer. This is a big no-no. R plus 10 squared means that you're multiplying the parentheses by the parentheses. So r plus 10 times r plus 10. A lot of people confuse r plus 10 squared with r squared plus 10 squared. They're not the same thing, okay? So again, r plus 10 to the second power means r plus 10 times the entire binomial by itself. Okay, so first let's go ahead and identify our a and b because I want to use the rules. I don't want to do the entire distributions of r and then 10, right? No, I want to use the a and b. So I can see that my a value is r, and then I can see that my b value is 10. So our expansion will look like a squared, so r squared plus 2 parentheses, so this is a squared, a, so a is r times b, so 10, and then plus b squared, which is 10, right? So this becomes r squared plus, here we can multiply the 2 and the 10, so plus 20r plus 100. Now let's try another example. So for this one we have h minus 1 squared, right? Again, let's identify our a value and our b value. So a is the first one, so a equals h, and then b equals 1. Notice how I'm not putting -1, just 1, right? Oh, I meant to put that in blue. So b equals 1. Okay. So again, our formula says that we have a squared. Now because this is a negative, it's going to be negative 2ab and then plus b squared. So this will be h squared minus 2 times h times 1 plus 1 squared. So I plugged them in, right? That was a replacement that I did with a and b. And this becomes h squared minus 2 times 1, which is 2h, and then plus 1, which is 1 squared. Okay? Let's go ahead and try another example. So this one is 2p plus 3q squared. So our a equals 2p. So notice a is not only 2, a is not only p, a is a product of 2 and p, so 2p. Then we have b equals 3q. Because we have a plus, right, then we're going to use the first rule, so a squared plus 2ab plus b squared. Can go ahead and plug in everything. So instead of a, this is 2p squared plus 2 parentheses 2p. B is 3q, so times 3q, and then plus parentheses 3q squared. So the first one is going to be 4p squared, right? Then on the second term, this 2 can actually multiply the 2, right? And then multiply the 3. So 2 times 2 is 4, and then times 3 is 12. So 12, and then the p and the pq, right? So that will be 12pq. For a moment I thought that q was a p, but they're not the same variable, so we just bring down pq. And then plus 3 squared and then q squared, which is 9q squared. And nothing can be added, right, or combined because they're all different terms. So this is our solution. So we're gonna be careful with what is our a and b. Sometimes there are gonna be more than one value. We're gonna have variables and numbers, and we gotta understand how to apply the rules of exponents, right, to get the squares, and then when it comes to multiplication.